Good evening, students. How are you all? I hope you had an amazing weekend. So, did you remember that when we completed last time, what were we doing? We were just done with power indeterminate forms. Last time we solved a question on power indeterminate form. I hope you remember. But let's get into more detail to understand properly what are power indeterminate forms. So, power indeterminate forms, we have three forms that are 0 raised to 0, infinity raised to 0, and 1 raised to infinity. Now, if you have studied limits, then you should know that we have different method for 1 raised to the power infinity. But no worries, we can solve it by the same method as we solve 0 raised to 0 and infinity raised to 0. So yeah, let us understand how to evaluate power indeterminate forms. So to solve, take log on both the sides. जैसे if I want to solve a limit where if I check the indeterminate form, it is 0 raised to 0 or infinity raised to 0. So we take log on both the sides and convert into 0 upon 0 or infinity upon infinity form. Now, please understand, for this, we need to know how to interchange or how to interconvert the indeterminate forms. For example, suppose my indeterminate form is 0 into infinity. Now, how do I convert 0 into infinity into a 0 upon 0 or infinity upon 0 form? So it is very simple. As we all know, infinity is any quantity upon 0. So I can write infinity as 1 upon 0. So I can write it as 0 into 1 upon 0, and which gets converted into 0 upon 0 form. So this is one way to convert 0 into infinity into 0 upon 0 form. So what have we learned? For power indeterminate forms, we have to take log on both the sides. If I take log on both the sides, then probably my indeterminate form after taking log would look like 0 into infinity. So if I want to further solve the limit, I need to convert 0 into infinity into 0 upon 0 or infinity upon infinity form. So yeah, how to convert 0 upon infinity? Just take a reciprocal of the infinity term. So we'll get 0 upon 0 form. Now, if you are clear with this, let's move on to some examples. It will take hardly 15 minutes for the examples. So yeah, let's see. Suppose I need this. Like someone asked me to find the value of limit x tends to 1, x raised to 1 upon x minus 1. So let us check the indeterminate form. Indeterminate form means x की जगह पे 1, 1 raised to 1 upon 1 minus 1, which is 1 raised to infinity. So it is 1 raised to infinity form. So what do we do? Take log on both the sides. So for both the sides, there should be an other side. There is no other side here. So let the limiting value be L. L equals to limit x tends to 1, x raised to 1 upon x minus 1. Take log on both the sides, log to the base e. So ln L will be equals to limit x tends to 1 log of x raised to 1 upon x plus 1. That will come in front and I will get upon x minus 1. You know this property of log? It is very important here. Log of m raised to n. I can write it as n in the front. So I get n log m. So this property I have applied here. M की जगह पे x and n की जगह पे 1 upon x minus 1. So I hope it is clear. Now let us again check the indeterminate form. So x tends to 1. This is ln1. Log of 1 is 0. Upon 1 minus 1, it is again 0. So my indeterminate form from 1 raised to infinity got converted into 0 upon 0. And we know that if the indeterminate form is 0 upon 0, I can use L'Hopital's rule. Or I would like to say LH rule. So LH rule, what says LH rule? You differentiate numerator and denominator. So ln x का derivative 1 upon x का derivative 1 minus 0. As you can see, indeterminate form is gone. So my answer is limit x tends to 1 upon x. So no need for me to write the limit. Just substitute the value of x. So 1 upon 1 will be equal to 1. But please take care here. This is the value of ln L. I want the value of L. So what will be the value of L? It will be e raised to 1 or simply e. This was I was talking about in the last class. One of them you didn't understood, so that's why I'm repeating here. So I hope you got it this time. If the format is power indeterminate form, we take log on both the sides. We use this property of log and then convert the indeterminate form into 0 upon 0 and then use LH rule. Chalo, let's see one more last question and then we'll move on to the next interesting chapter, which is continuity. So, next question. Okay. Here it is given limit x tends to 0 cos x raised to 3 upon x square. Let's look at the indeterminate form. What is the indeterminate form here? Cos 0. Cos 0 is 1. 3 raised to 0. Raised to 3 upon 0. 3 upon 0 means infinity. So again it is 1 raised to infinity, which is a power indeterminate form. What do? We take log on both the sides. For both the sides, we need the other side. So we write the limit as L equals to limit x tends to 0 cos x raised to 3 upon x square. Now, if we take log, I will get ln L is equals to limit x tends to 0 ln cos x. And जो रेशियो था वो आगे आ जाएगा तो I will get 3 upon x square. Now, if you check the indeterminate form, 0. Cos 0 is 1 and ln 1 is 0 upon x is 0. So my indeterminate form is 0 upon 0. So I can use LH rule. If I use LH rule, limit will be 3 will remain as it is. 3 is a constant. So 3 will remain as it is. Limit x tends to 0. Now, do you know the differentiation of ln cos x? Anyone? Differentiation of ln cos x. ln cos x का differentiation. ln cos x का differentiation. You need to have chain rule. Chain rule, right? Okay, 1 second. We have extra maths class. Means extra maths class. So this is this. After this, you have one more extra maths. Hello, am I audible? Extra maths class means? Acha, your syllabus is running late, therefore you have extra class. Okay, no problem. But still, we have to complete this, right? Okay, let's complete this first. So, limit x tends to 0, ln cos x. What is the derivative of ln cos x? 1 upon cos x into derivative of cos x, which is minus sin x. So 1 upon cos x into minus sin x upon what is the as you can see, the indeterminate form is 1. So I can easily put the value of x. So x, if I put 0, I will get minus sine 0 upon cos 0. What is the value of sine 0? It is 0. So 3 into 0 is 0. But don't forget, the value is ln L. We want L, which will be e raised to 0, which is equals to 1. Anything raised to 0 is 1. So these are some questions which you should do. You should practice for like power indeterminate forms. Just it's very simple. Take log on both the sides, convert into 0 by 0, and simply use LH rule. So if you are done with this, let me tell you. Now we will be doing continuity. The next chapter is continuity. So let's start with continuity. If I start with continuity, where is here is continuity. So let's start. What is the simple meaning of continuity? Chalo. If someone asks you what is continuity, don't think about maths. Just think about what is continuity. So if you look up into a dictionary, continuity means like unbroken. It is not broken anywhere. So example, I can say unbroken road between two cities, which is very difficult to find in India. There are many broken potholes. Okay. And we can say railway tracks. Railway tracks are also unbroken. They go continuously. And lastly, the changing temperature of a city during the day. This is important. Like if in the morning it was 30 degrees Celsius and at the night it comes to 20 degrees Celsius. That means from 30 to 20, it must have taken every value while decreasing 29.9, 29.8, 29.7, and so on. It must have taken every value for from 30 to 20. So these are examples of the word continuity. Now, what does continuity means to us? To us means in mathematics. So continuity, as we know, calculus, if you forgot, calculus is basically like a post-mortem of a function, like how the function behaves, where is the maximum value, is the function continuous, is the function differentiable, how the function behaves at a point which is not in the domain. So basically we study calculus to do post-mortem of a thing called function. So let me tell you, we have studied limits. Limits help us to understand the behavior of the function. Limits helps us to understand the behavior of the function adjacent, left and right of the point which is not in domain. So what is the importance of continuity here? Continuity helps us to see whether the function is broken or not. So continuity, what is the significance for continuity in calculus? It just helps us to understand whether a function is broken or not. So let us see here very simple graphs I have. This is the function f of x. At a, you can see there is no functional value, means there is a hollow circle. Hollow circle means there is a break in the function at x equals to a. That means that function is broken, and that means this function is not continuous. Same example you can see here. The next one also at x equal to a, the function is broken. On the left side of a, it is this, and on the right side of a, it is this. So again, you can clearly see function is broken, means the function is discontinuous. This is a very simple meaning of continuity. But let me tell you again, there will not always be graphs. There will not always be graphs. So that we can easily see whether the function is continuous or not. So that's why we need some mathematical tools or mathematical methods so that we can use those and see whether the functions are continuous or not. So let's see how mathematically we define continuity. So a function is said to be continuous at point x equal to a if three conditions are satisfied. That is, the function f is defined at x equals to a. Means functional value at a is a defined value. Next, limit x tends to a, f of x exists. Now we all know the limit is in two parts. That is LHL and RHL. Both are same. That means the limit exists. And third, the limiting value should be equal to the functional value. So there are three conditions, and if you ask me, I to say there for me there is only one condition. That is the third one. First and second conditions are covered in the third one. That means the limiting value should be equal to functional value and limit must exist. That is LHL should be equal to RHL. Now, let's take the same example, same graph, and you can see, let the value of function at x equal to a be 3. So, if someone asks me the left hand limit, so if I approach a from left hand side, the functional value I am approaching is 3. So here left hand limit is equals to 3. What is the right hand limit? Right hand limit is also equals to 3. Means this is satisfied. But as you can see, at exact A, we have a hollow circle. That means the functional value at A does not exist. And if it does not exist, that means the first condition is violated. That means this function is not continuous, which we can easily see from the graph, as we have seen in the previous slide. Now let's look at the right example. Suppose this value is 3 and this value is 5. So if I approach A from left hand side, my graph approaches 3. That means left hand limit is 3. If I approach A from right hand side, my graph approaches 5. That means right hand limit is 5. So here I conclude that LHL is not equal to RHL, means the limit does not exist. And if limit does not exist, the function cannot be continuous. And you can clearly see from the graph, the function here is not continuous. So again, let me revise how to check continuity. The functional value should be defined, limit should exist, and the functional value and the limiting value both should be same. Functional value exists, limiting value exists, functional value and limiting value both should be same. So let's move forward and see right continuity and left continuity. As we know, we have right hand limit and left hand limit. Similarly, we have right continuity and left continuity. It is very simple. A function is said to be right continuous if limit at x equals to a. If the right hand limit is equals to the functional value. And same, the function is said to be left continuous if the left hand limit is equals to the functional value. As simple as that. Right continuity means RHL should be equal to functional value. Left continuity means LHL should be equal to functional value. Obviously at the given point means at x equals to a. So I hope this is clear. It is a very simple concept, but we will use this very importantly in the coming questions. So let us move and see some examples. For example, here I have two questions. Discuss the continuity of the function at x equals to 3. And this is a function. As you can see, it is a piecewise defined function. I hope you remember. It is a piecewise defined function. So let's check all the three conditions. First, the functional value at x equal to 3 means just input x equal to 3. So which definition will I use? This one, because here it as an equality. So I will get 3 square plus 3 upon 2, which is 9 plus 3 upon 2. 3 upon 2 is 1.5. So that means 11.5 functional value is defined. So condition 1 check. Let's look at if limit exists. So we have to calculate LHL, meaning limit x tends to 3 minus of f of x. Now, here x tends to 3 minus means x is less than 3. I hope you got this. X is less than 3. And which definition will I use? This one. Here it is x is less than 3. So meaning limit x tends to 3, x square plus 3 by 2. There is no indeterminate form. So we directly substitute x ki jagah pe 3. And if you see, we will get the same 11.5. Now let's check right hand limit. Right hand limit means limit x tends to 3 plus. That means x is greater than 3. Now, if x is greater than 3, which definition will we use? This one. That means I can write limit x tends to 3, 5x minus 4.5. Again, there is no indeterminate form. That means directly substitute here. 5 is a 15 minus 4.5 is 11.5. So left hand limit is equals to right hand limit, implies limit exists. So, and one more thing, functional value exists, limit exists. Last we have to check functional value and limiting value are same. The functional value and the limiting value both are same. That means the function is continuous. I can write the function is continuous at x is equals to 3. I can easily write the function is continuous at x equals to 3. Now, let's look at next question. F of x equals to mod x, our favorite function, modulus of x. So, what is modulus of x? Modulus of x has two definitions. It is x when x is greater than or equals to 0, and it is minus x when x is less than 0. So, again, we have to check three things: the functional value, limiting value, and if both are same at x equals to 0. So if I check the functional value, here there is equality, so we'll use this definition. So it is 0, simple, x ki jagah pe 0. Now let's check left hand limit. Left hand limit means limit x tends to 0 minus means x should be less than 0. Now, if x is less than 0, x is less than 0 means you have to use this definition. So it is minus x. No indeterminate form, simply substitute minus 0, which is equal to 0. Right hand limit. What is right hand limit? Limit x tends to 0 plus. And if x tends to 0 plus means x is greater than 0, again we will use this definition, which is x, again no indeterminate form, 0. LHL equal to RHL, and both the functional values are same. Both the functional values and the limiting values are same. So we can say it is continuous at x equals to 0. This is my final result. I hope you got it. Right? So it is very clear. We have to just check three things, very simple questions. Now, after this, let's talk about the properties of continuous function. That means if I have two functions, f and g, and both are continuous at x equals to a, then this means f plus g is continuous, f minus g or g minus f is continuous, k into f, any constant multiplied by f is continuous, f into g, product is continuous, their division is continuous, and their composite functions, fog and golf are continuous. We are talking about all this at point x equals to a. So that means the function f and g continuous implies addition, subtraction, multiplication, division, and composite functions made from all these are also continuous. This helps us in basically many problems where we have composition of functions. So, if it is clear, very simple to understand properties of continuous functions, let's move forward and see something interesting, which is types of discontinuity. So, we all know that some of the function will be discontinuous. So, according to our observation, we have distributed the types of discontinuity in two parts. The first one we say jump discontinuity. Jump discontinuity, meaning there is a jump in the function. The function jumps from one value to another. Now, what that means algebraically? Algebraically means the left hand limit and right hand limit are not equal. The left hand limit and right hand limit are not equal. The same example we took here, as we saw, the left hand limit was 5 and the left hand limit was 3 and the right hand limit was 5. So both are not equal. In this type of discontinuity is jump discontinuity. And you can see from the graph that the function jumps here. From 3 to 5, the function jumps directly. It doesn't take any value between 3 and 5. So that's why the name is very logical. The function jumps means jump discontinuity. Now, again, the mathematical way is to just calculate the left hand limit and right hand limit. So, here is a very simple example. F of x is given for -4 to -2 and -2 to 1. There are two definitions and we have to check at x equals to -2. So if we check at x equal to -2, what is the left hand limit? Left hand limit means limit x tends to minus 2 minus. That means the limit f of x. This means x is less than minus 2. So if x is less than minus 2, we use this definition. So I can write limit x tends to 2 minus 2 x square minus x minus 5. No indeterminate form. We just substitute minus 2. So minus 2 square minus of minus 2 minus 5. 4 plus 4. 8 minus 5, we get the left hand limit as 3. Now let us calculate right hand limit. Right hand limit will be limit x tends to minus 2 plus. Now minus 2 plus means x is greater than minus 2. So we'll use this definition. So I will get limit x tends to minus 2. F of x means x cube minus 4x minus 3. Now, no indeterminate form, use direct substitution method. So minus 2 cube minus 4 into minus 2 minus 3. Now, what is this value? Can you calculate this? Minus 8. This will be plus 8 minus 3. So that means we get minus 3. We can see left hand limit and right hand limit are not same. And if left hand limit, right hand limit are not same, that means the function has a jump discontinuity. Okay, that means the function jumps. Very common name. Now, this is the first type of discontinuity, which is jump discontinuity. There is a second type, which is known as removable discontinuity. LHL is 1. They made a mistake. No, please see. Beta, minus 2 ka square is 4. This minus and this minus will get plus 4. So 4 plus 4, 8 minus 5 will be 3. Did you get it? It is not 1. Hello? Right? I think I have not done calculation mistake here. 6. No, how it will be 6? 4 plus 4, which is 8. And 8 minus 5 is 3. RHL me talking. Minus 8 plus 8 minus. No, it is right. Both calculations are right. Please check. Any problem? How are you getting 6? Am I right? Got it? It is 3. Please confirm. It is 3, na? Right? Hello? Yes. Where did 4 come from? We substituted minus 2 here. If we substitute minus 2 here, then minus 2 का square is 4, right? Minus 2 को substitute करो. Minus 2 का square is 4. And here minus is already there. And x की जगह पे minus 2. So minus minus it will be plus 4. And minus 5. We are using this definition na, for less than minus 2. LHL is 1. How are you all saying 1? Okay, got it. Here it will be 4. Nahi, barabar. Right. My mistake. Here it will be 2. Sorry. So yeah, LHL will be 1. Right. Okay, okay. Got it, got it. Thank you, thank you. So LHL is 1. No problem. Still they both are not same. Means they are discontinuous. Okay. Got it, got it. Thank you. Chalo. Let's move on to next, which is removable discontinuity. Removable discontinuity means uh, here we can see some functions may be discontinuous, but if we change something, like if we change the functional value of the function becomes continuous. That means mathematically we can see the left hand limit is equals to right hand limit, but the functional value is not same. The limit's value is same, the limit exists, left hand limit and right hand limit is same, but it is not equal to the functional value. So such case exists, then the function, then the discontinuity is removable. As the name suggests, we can remove the discontinuity by redefining the function. Now, how do we redefine the function? Let me tell you. First, look at this example. Here, suppose say this value is 3 and this value is 5. So if I approach from left hand side and right hand side, my limiting value is 3. But if I take f of a, the functional value, here it is a solid circle, so the functional value is 5. Means the limiting value is 3, but the functional value is 5. If such cases, that means limiting value and functional value are not equal. That means the discontinuity is removable. Now, what to do? It's very simple. Just bring this solid circle over here. So this will become solid. And if this becomes solid, the function will get continuous. Now, how do we bring just a solid circle over hollow circle? We basically just redefine the function, that is, write the functional value equals to limiting value. That is, I will directly write the functional value not as 5 but as 3. This process is known as redefining the function. You will be very clear if we see some examples. So let's see some examples. Here I have discuss the continuity of the function at x equals to 2. So continuity at x equal to 2, we have to check 3 things: the functional value, limiting value, and if both are equal or not. Functional value I cannot put 2 because this value is valid when x is not equals to 2. So that means I cannot find the functional value. That also means functional value is undefined. So let us check the limiting value. So if I check limit, x tends to 2. Now here no need to check LHL and RHL because we have only one definition. Here we had in these examples, we had two definitions, definition 1 and definition 2. So no need to check LHL and RHL when the function only has one definition. So we can directly find the limit x square plus 3x minus 10 upon x cube minus 8. If you check, the indeterminate form is 0 by 0. That means if I use LH rule, what I'll get? X square का derivative 2x plus 3 upon 3x square, and 8 and 10 का derivative 0. So I have not written. Now I think indeterminate form is gone. So I will write 2 into 2 plus 3 upon 3 into 2 square. 2 2s are 4 plus 3, 7 upon 2 2s are 4 3s are 12. So the limiting value is 7 upon 12. Functional value we don't know. So this means the basically function is discontinuous. That is, there is some hollow circle here at x equals to 2. Okay, but we can fill this circle by redefining the function. Now let's see how to redefine the function. So therefore, I will redefine the function as I will write this same x cube x square plus 3x minus 10 upon x cube minus 8 for x not equals to 2. And for x equals to 2, which is the functional value, I will write the same limiting value here. Write the functional value equals to the limiting value. So at x equals to 2, my value will be 7 upon 12. So now the limiting value and the functional value both are same. That means I have made the function continuous by redefining the function. So the original function was given this, but I redefined the function as this. That means now the function is continuous. Now the function is continuous. Okay. So let's see next. Till now, we have been using continuity at a point. The example continuity at x equal to a. Now let's look if what happens if we are given an interval. Like if someone asks me to check this one, redefining the function. Okay. So what we did here basically, we found the limiting value, which came as 7 upon 12. Now, as we all know, limiting value means it is not for 2. And as we can see here, the functional value at 2 will be not defined because denominator will have 0. And anything upon 0 is not defined. Barabar? That means my function, my graph can be of the form like this. We have taken this example, a hollow circle and this. At x equals to 2, limiting value is 7 by 12. That means from left hand side and from right hand side, I am approaching 12. But here is a hollow circle. So if I try to find f of 2, we'll get not defined. That means here it is hollow circle. Means the function is discontinuous at x equals to 2. As you can see here. In this example, let me rub it out. Yeah. Here the functional value is still there. But in our case, there is no functional value. There is no solid circle. That means the functional value is not defined. And if the functional value is not defined, the function is discontinuous. Because continuity, what were the criteria? First, functional value should be defined. Limit should exist. And third, limiting value should be equal to functional value. So here limiting value is existing, but functional value is not existing. So by redefining the function, we make the functional value exist. That is, at x equal to 2, I directly put the functional value will be 7 upon 12. So if someone asks f of 2, then from this redefinition, when x equal to 2, my functional value is 7 upon 12. Which is again the limiting value as we have calculated here. So all the three conditions are satisfied. The functional value exists, yes. The limiting value exists, yes. And both are equal. So this makes the function continuous. So how do we redefine the function? We just have to do one thing. We just have to write the functional value equal to the limiting value. That's what we did here. I found the limiting value. and I wrote the functional value as the limiting value. Simple. Is it clear now? I hope it is clear. Hello? All good? Hello? Okay, fine, fine. Good, very good. So, let's talk about continuity in an interval. So, we were here that if someone asks me from this to this interval, I need to check whether my function is continuous or not. So, that means this is the basically meaning of continuity in an interval. Okay. So, let me tell you that uh, suppose we took an interval from 1 to 2. Okay. So there are infinite number of points between 1 and 2. So it is not possible for us to check continuity at every those points. So for that, we defined some standard functions. What are standard functions? Basically logarithmic function, sine, cos, trigonometric function, exponential function, polynomial function. So we say that all these functions are always continuous in their domain, as you can see. If I take exponential function, its graph look like this. Here it is 1. So as you can see, if I take an interval, it is always continuous. So we defined a logic that if my function is a standard function, then we can say directly without checking, it will be continuous in its domain. But if my function is a piecewise defined function, means the definition changes at some point, then I need to check for continuity at that point. Meaning the point where the functional definition changes. Got it? So no need to go or calculate continuity at every point in an interval. Basically, we just calculate the continuity where there is a chance that the function might break. That is, for piecewise defined function, there might be a chance that the function might break where the definition of the function changes. So this continuity interval is basically, I would like to say, for piecewise defined functions. So where the definition changes, we check continuity at that point. Got it? Let's look at this example. Now, if someone asks me to discuss continuity of function f of x equal to x minus 3. So, if they does not give me to check at x equal to 3 or not, they say discuss the continuity of the function in the domain of the function. Since we know this is the modulus function, the domain of the function is all real numbers. So now, if obviously it is not possible to check on all the real number the continuity, so where I will check? I will check where the functional definition of this modulus function changes. That is, I can write the function as f of x equal to x minus 3 and 3 minus x. If x is greater than equals to 3, 3, and x is less than 3. Okay. So now for x is less than 3, this function is a polynomial function. So we directly say by standard function, this is a polynomial function, means it is always continuous. For x greater than 3, we say this is again a polynomial function, linear polynomial, it will be a straight line. So we say that it is also continuous for x greater than equals to 3. But since the function changes its definition at x equals to 3, there is a chance that it might break at that point. So we need to always calculate at that point, the continuity at that point. All the rest of the points we can directly say this is polynomial, hence it will be continuous. Got it? If they ask for a specific point, that previously they asked continuity at x equal to, we have to check only at 3. But if they don't give a point, that means they are expecting us to check where the function can break. So in that case, we have to use our mind. Okay. So let's take this example. Now we'll check at x equal to 3. We have to check three things. The functional value at 3, equality is here. So we'll use this definition. So 3 minus 3, which is 0. The functional value exists. Let's check limit. Now we have to check both LHL, RHL since the function is splitted. So LHL. LHL means limit x tends to 3 minus. So less than 3 means this definition 3 minus x, which is 3 minus 3, which is 0. Now let's check RHL. RHL means limit x tends to 3 plus. 3 plus means this definition. So I will use x minus 3. No indeterminate form. So 3 minus 3, which is equal to 0. Now check. LHL is equals to RHL, means limit exists. And the three values, the functional value and the limiting value are same. Means we had already decided that function is continuous for greater than 3, function is continuous for less than 3. And now by this, we can say function is continuous at x equal to 3. That means less than 3, greater than 3 and equal to 3. Implies continuous for all x belongs to real numbers. Got it? So if the continuity point is not mentioned, that means they expect us to check the continuity where the function changes its definition. Okay, let's look at one last example here. Test whether the function is continuous at x equal to minus 4. Same thing we'll do. The functional value at minus 4, it is directly given, which is 8. Now see, this one where x is not equals to minus 4 is not splitted in two parts, less than and greater than. So if it was splitted in less than greater than, we will find both the limits, LHL and RHL. But since it's not splitted, we no need to find both the limits. We can directly find only one limit, that is limit x tends to minus 4. X square plus 16x plus 48 upon x plus 4. You can say this is a 0 by 0 indeterminate form. That means we have to use LH rule. So limit x tends to minus 4, 2x plus 16 upon 1 will get. So indeterminate form is gone. So I can write 2 into minus 4 plus 16, which is minus 8 plus 16, which is 8. So all the three definitions are satisfied. The functional value exists, limiting value exists, and the functional value, limiting value both are equal. Implies function is continuous at x equals to minus 4. Now, that is I am saying, suppose if they don't give x equal to minus 4. Suppose they just say test the continuity of the function. So we should know that since at x equal to minus 4, the definition changes. The functional value is different and the limiting value, like the function, changes into two parts. So here we have to use our own mind to see ki, we'll check at x equal to minus 4 because the function is changing definition at x equal to minus 4. Got it? So this is continuity. I guess we have some more questions remaining, 3, 4 questions. We'll do it next time, means tomorrow, and we'll be starting with differentiability, the next chapter. Very interesting chapter. Now you should know that limits give the behavior of function in the neighborhood. Continuity checks the whether function is broken or unbroken. And what does differentiability do? We'll see it tomorrow. So basically, throughout the calculus, we'll just analyze the function, how the function behaves and all. Got it? Yeah. So let's end here. Okay. See you soon. Tomorrow, same time.